Okay, so here we are in section 8.5, and this is all about rationalizing the denominator. Now, we did see some simple examples of this before, but in this section we'll look at a little bit more complicated ways to get rid of a radical in the bottom. So if I want to simplify this and get rid of the radical, well, I have to multiply top and bottom by whatever it takes to get rid of that radical in the bottom. And that is simply square root of 5 over the square root of 5. And so if I multiply out, what I get is the square root of 15 plus 2 square root of 5 over 2 times 5, or 10. And that's a simple example of rationalizing the denominator. So let's look at one that's a little bit more interesting. So if the denominator is something like a plus the square root of b, we're going to want to multiply top and bottom by a minus the square root of b. And that reason for that is if you take a plus the square root of b times a minus the square root of b, what you get when you multiply them is a squared minus b. And there is no radical there. So that's the trick. And this thing, a minus the square root of b, let's see, where can I write that? This is the conjugate of a plus the square root of b. So that word conjugate you'll be seeing a lot of. Basically it's the same as this, except the sign is a minus instead of a plus. So let's look at a couple of examples that work with this. Alright, so here's an example that illustrates what we were just talking about. So I want to multiply top and bottom by the conjugate of this. The conjugate is exactly the same except the sign changes. So it's going to be square root of 2 plus 5 times the square root of 2 plus 5. When I multiply on the top, I get 3 times the square root of 2 plus 15 over, if I multiply on the bottom, I'm going to get 2 minus 25. Make sure you see how that happens. And so basically the easiest way to write this would be put a minus sign out in front, and I have 3 square root of 2 plus 15 over 23. Alright, so that's what happens when you have an expression that's a little bit more complicated than just a radical, but not too bad. Alright, we'll practice some more. Alright, so this is even more complicated in terms of what we have on the bottom, but the conjugate is still the same idea. Exactly the same as this, except the sign is different, so it'll be a plus. So we're going to multiply top and bottom by the conjugate of this and see what happens. So here again, press pause, check it out, see what you get, and hopefully we will agree. So this is what it should look like, and obviously we're not done, because the square root of 98 can be simplified, the square root of 28 can be simplified, and 7 minus 2 is 5. So once again, I'll try to do some work, and you try to do some work, and let's see if we can meet. Alright? Okay, we good? Sort of running out of room here, so I got to be a little bit more careful. But now I'll take these roots, and what I get is 7 square root of 2 plus 2 square root of 7 minus 2 square root of 7 minus 2 square root of 2 all over 5. And now I add my like terms. Here's a square root of 2, and here's a square root of 2, here's a square root of 7, here's a square root of 7. So if I simplify all of that, let's see what I get. I have 7 root 2 minus 2 root 2 is 5 root 2. And then these cancel, This is all over 5. And so, believe it or not, this whole thing simplifies to just the square root of 2. Wow, who would have guessed that? That's kind of fun with these problems. All right, we'll do one more that deals with variables instead of numbers. Okay, so let's do this. Why don't you try to work through this entire problem, and we'll see where you get and where I get, and hopefully it's the same place. So get ready to press pause, and I'll put the entire solution out, and we'll see how we do. So a lot of work in here. Let's just kind of go through this. Here's my conjugate, multiplying top and bottom. So it's a good idea not to multiply the top out, to leave it in factored form, because we want to try to factor things as much as we can. Here's what I get on the bottom. And what I can do now is out of the bottom I can factor out an AB, and that leaves me with A minus B. And then nicely these AB terms cancel, and I wind up with my final expression. So, a lot of cool work we're doing here, and hope you're getting it. And if not, we'll talk about it in class. And that'll be it for this section. See you next time.